Hello everyone, welcome to Unique Beam. In this video, we embark on a spectacular voyage through the life cycle of stars, from the tranquil beginnings in the vast cold nebulae to the violent finales as supernovae. Stars, the fundamental core blocks of galaxies, illuminate our skies, and forge the very elements that make up the world around us. We'll uncover the processes that fuel a star's birth, life and death, and reveal the crucial role these celestial phenomena play in the cosmic ballet. The life cycle of a star is a story of transformation and energy, where simple clouds of gas and dust evolve into glowing orbs of heat and light. By understanding this cycle, we not only grasp the life story of individual stars, but also gain insight into the dynamic and ever-changing nature of the universe itself. Let's delve into this fascinating journey that stretches across billions of years and through the vast expanse of space. Our story begins in the nebulae, the great nurseries of the cosmos. These vast clouds of gas and dust are more than just spectacular vistas. They are the cradles of star formation. Under the influence of gravity, parts of these clouds collapse and condense into denser regions where the pull of gravity becomes stronger, drawing in more material. Over millions of years, these growing clumps of gas and dust heat up as they accumulate more mass, eventually forming what we call a protostar. This early stage is crucial as it sets the foundation for a star's life. Protostars continue to draw in material, growing hotter and denser until the conditions at their core allow nuclear fusion to ignite. This is the process by which stars convert hydrogen, the most abundant element in the universe, into helium. The energy released from this fusion provides the outward pressure needed to counterbalance the inward pull of gravity, establishing a stable star that will shine for millions to billions of years. Once a star has ignited its nuclear furnace, it enters what is known as the main sequence phase, the longest period in its life cycle. For a star like our Sun, this phase can last about 10 billion years. During this time, the star continues to fuse hydrogen into helium in its core, producing tremendous amounts of energy. This energy not only powers the star's luminosity, but also supports the star against gravitational collapse, maintaining a state of equilibrium. The main sequence phase is characterized by a delicate balance between the gravitational forces pulling the star inward and the energy from nuclear fusion pushing outward. The size, brightness, and lifespan of a star during this phase depend primarily on its initial mass. The more massive the star, the shorter its life on the main sequence. As stars exhaust the hydrogen fuel in their cores, they undergo dramatic changes in structure and appearance, leading to the next stages of their life cycles. For medium-sized stars like the Sun, this means expanding into red giants. For more massive stars, they become supergiants. In both cases, the star expands as the core contracts and the temperature rises, allowing helium and heavier elements to begin fusing in shells around the core. The expansion into a red giant or supergiant marks the beginning of the end for a star. These stages are characterized by increased luminosity and significant changes in the star's color and size. The outer layers expand and cool, giving the star a reddish appearance. This phase is relatively short compared to the main sequence, lasting only a few million years. As we prepare to dive deeper into the final stages of a star's life and its incredible transformation, this is the perfect time to show your support. If you're fascinated by the mysteries of stellar evolution, make sure to subscribe to Unique Beam and give this video a like. Your support keeps our exploration of the universe burning bright, allowing us to bring the cosmos closer to you. Now, let's continue our journey through the dramatic final phases of a star's life, where the most awe-inspiring cosmic events unfold. As red giants evolve, they undergo a series of internal changes that culminate in the shedding of their outer layers, creating what is known as a planetary nebula. This stunning transformation occurs when the core of the star no longer has sufficient fuel for fusion, causing it to collapse under its own gravity. This collapse increases the core's temperature, expelling the outer layers into space. The exposed hot core, now called a white dwarf, shines brightly and illuminates the expelled gas, producing a colorful display observable from great distances. A white dwarf represents the final observable stage of a star's life cycle for medium-mass stars like our Sun. These dense, hot remnants slowly cool and fade over billions of years, eventually becoming what is known as black dwarfs, hypothetical stellar remnants that theorists predict, but which the universe has not existed long enough to produce. Massive stars, which start out with much more mass than the Sun, meet a more explosive and spectacular end. When a massive star exhausts its nuclear fuel, it undergoes a dramatic collapse known as a supernova, an explosion so bright that it can outshine an entire galaxy for a short period. This catastrophic event occurs because the core of the star, now composed mainly of iron, cannot produce energy through fusion. Without the outward pressure generated by fusion, the star's immense gravitational force causes the core to collapse, resulting in a shock wave that rips the star apart. The remnants of this explosion can lead to one of two fascinating phenomena, a neutron star or a black hole. Neutron stars are incredibly dense, composed almost entirely of neutrons, and often emit beams of radiation that we detect as pulsars. If the core's mass is sufficient, it may collapse further into a black hole, an object with gravity so strong that not even light can escape. Supernovae play a critical role in the cosmos. They are key to the synthesis of heavy elements, which, through the explosion, are scattered across space and incorporated into other celestial bodies, forming new stars, planets, and even life itself. Furthermore, the shock waves from supernovae can trigger the formation of new stars in nearby clouds of gas and dust, influencing star formation in a galaxy. Observations of supernovae have also been crucial in understanding the expansion of the universe. For instance, certain types of supernovae with known brightness are used as standard candles to measure distances in the universe, leading to the discovery that the universe's expansion is accelerating. The life cycle of stars, from nebulae to supernovae, showcases the dynamic and ever-evolving nature of the universe. Each stage of a star's life contributes to the cosmic dance of creation and destruction, influencing the formation of galaxies and the distribution of elements necessary for life. By studying these celestial phenomena, we not only unravel the history of the cosmos, but also gain insights into the potential future of our own solar system and beyond. Thank you for joining us on Unique Beam, as we explored the fascinating life cycle of stars. If you enjoyed this journey through stellar evolution and are eager to discover more about the universe, don't forget to subscribe to our channel and like this video. Your support fuels our passion for uncovering the secrets of the cosmos and sharing them with you. Stay curious and keep your eyes on the stars, as each one holds the key to understanding our past and future in the vast universe.